Alright, so in this video we're going to be talking about system of equations and how to solve your system of equations. So there are a couple different methods you can use to solve system of equations, but first let's just talk about what a system of equations is and what the solution actually is that you're finding. So a system of equations is when you have two sets of equations where each equation has two variables and they share those variables. So for example, a system of equations would be y equals 3x plus 1 and y equals 2x minus 3. So as you can see here, we've got two equations. Each equation has two variables and it's the same variable. This first equation has the variable x and y, and this one also has x and y. Now if you had, say for example, if we changed this second equation to have z equals 2x plus y, that would now make this have x and z, which would give you a total of 1, 2, 3 different variables and only two equations. So you couldn't solve that system of equations, all right? In order to solve a system of equations, you've got to have the same number of equations as you do unknown variables. So that's really important. In order to solve your system, must have same number of equations as variables. And so in this section, since we're just starting out, we're just going to look at two equations and two unknowns. And these unknowns here that I'm referring to are your unknown variables, which in our case, we're going to be looking at x and y. All right, so when you solve a system of equations, what that actually means is that you will have two different lines. For example, we'll just say these two lines here. And the solution to that system is going to be the point where they intersect. That there is your solution. All right, so there's a couple different ways you can find this intersection point for a system of equations. And of course, that first way is going to be by graphing. You can also use substitution or elimination. So we're going to go ahead and look first at graphing, since that is our literal definition of a solution to a system of equations. So graphing. All right, now let's say, for example, our system is, let's just look at y equals x and y equals 2x plus 1. So we're going to go ahead and just graph both of these equations. So I'm going to draw my coordinate plane here. Go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. All right, and we'll go ahead and graph these in different colors so you can see. So that's going to be our first equation we're going to do in green, and then our second equation we'll graph in red. So let's go ahead and graph this first equation here. So we're going to graph by using our point, or our slope-intercept form. So we're going to go ahead and identify the slope, which in this case is 1. That's the value right before the x. And then our y-intercept in this case is 0, because we don't have any additional stuff going on out here. So our y-intercept is 0, so we're going to have a point there at the origin, and then our slope is 1, so we're going to go up 1 over 1, up 1 over 1, down 1 over 1, etc., etc. And so that's going to be our line for our first equation. So now we can go ahead and graph our second equation. Again, we'll identify our slope, which is going to be 2, because it's that value right there. And then our y-intercept is this value here, so that's going to be equal to 1. So we're going to go up on the y-axis up to 1, because that's our y-intercept. And then our slope is going to be 2. If you remember, slope is rise over run. So we're going to go up to 1, 2 over 1. Down to 1, 2 over 1. And that is our line for our second equation. So you can see that this point right here, that's where they intersect, so that's our solution. And so that's going to be -1, -1 is our solution to this system of equation. So, for example, though, if we look at something a little bit different, if we change, if I could erase these properly. Okay. If we change this so that we just have x plus 1 as our second equation, we're going to go ahead, our y-intercept is going to be the same, but our slope is going to change to 1 here. So again, we'll have plus 1 as our y, and then we're going to go down 1 over 1, up 1 over 1, and so on. And just like that. So these lines are actually parallel. So therefore, they will never intersect. So this system has no solution. All right. Now, a way you can identify that without graphing is by just looking at their slopes here. If your slopes equal each other, they're going to be parallel lines and they will never ever intersect. And so therefore, you will have no solution to your system of equations. All right. So let's go ahead now and take a look at another example. Let's go ahead and look at 3x plus y equals 2 and 2x minus 2y equals 4. Now, as you can see, you're going to have to graph these equations, right? So in order to do that, you're going to have to get this in slope-intercept form. So what you're going to do is you're just going to go ahead and put both of these into slope-intercept form. And so we can go ahead and do that. I'm just going to go ahead and move these side by side so we can work with them simultaneously. So we're going to go ahead and subtract 3x from both sides. So we're going to get y equals negative 3x plus 2 on that side. Subtract 2x. We have 2y equals negative 2x plus 4. Divide by negative 2 by everything. So you're going to get y equals x minus 2. All right, so you can see here, you can do a quick check. The slopes are different, so we are going to have a solution. And you can go ahead and just graph these. So here m equals negative 3, b equals 2, m equals 1, b equals negative 2. 1, 2, 3, ooh. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we'll go ahead and graph this first one over here. So 2 is going to be our y-intercept. And then we're going to go 1, 2, 3 over 1 in the negative direction. 1, 2, 3 over 1. That's our line there. Then we'll go ahead and graph this second equation here. Y-intercept negative 2, up 1, over 1, up 1, over 1. That's our line there. So as you can see, that's our solution right there where they intersect. Now, if you wanted to do this just algebraically without graphing, you can use either the substitution or elimination method. So let's go ahead and just talk about substitution first. So let's go ahead and look at an example of that. Let's say we've got y equals x plus 1 and 3x minus y equals 2. The way substitution works is you're going to take whatever value you have up here. So this x plus 1 equals y. So you can take this x plus 1 and plug it in for y right there. So you're just going to go ahead and take the y value from your first equation and substitute it into your second equation. So we know that y equals x plus 1, so we can go 3x minus our y from our first equation, which is x plus 1, equals 2. Now you can see in this equation here, we've only got one variable now, so we can go ahead and solve for x. So we're going to go ahead and distribute this negative 1 into the parentheses there. So we're going to go 3x minus x minus 1 equals 2. Combine our like terms, so 2x minus 1 equals 2. Add 1 to both sides. You're going to get 2x equals 3. X equals 3 halves. All right, so now we have our x. So now you can take that x and substitute it back into either one of your equations. So I'm going to go ahead and plug it into this first equation. So y equals x plus 1, where we know x is 3 over 2 plus 1. So y equals 3 over 2 plus 2 over 2. Y equals 5 halves. So that right there is your solution. So you're going to get 3 halves, 5 halves as your solution. All right. Now, if you're given a system of equations in, let's say, this form, 3x plus y equals 2, and 2x plus 4y equals 8. Now, as you can see, neither of these equations are set up in the x equals or y equals form, but you can go ahead and solve for that. So I'm going to take this first equation and solve for y. So isolate y on one side, everything else on the other. So in order to do that, I'm going to subtract 3x from both sides. And I'm going to be left with y equals negative 3x plus 2. So now I can take this and substitute it into here. So we've got 2x plus 4y, which we solved for y in our first system as being negative 3x plus 2 equals 8. And again, we're just going to simplify that. So distribute the 4. We're going to get minus 12x plus 8 equals 8. And combine our like terms. So we're going to get negative 10x plus 8 equals 8. Subtract 8 from both sides. And you're going to get negative 10x equals 0. Divide by negative 10. You're going to get x equals 0. And then go ahead and take this and plug it back into either one of your equations. It doesn't matter if you choose equation 1 or equation 2. You'll get the same answer either way. So I'll go ahead and just plug it into our first equation. So 3 times x, which we just found out is 0, plus y equals 2. So then you can go ahead and solve for y. So you're going to get 0 plus y equals 2, so y equals 2. So your solution is going to be 0, 2. And again, that's where those lines are going to intersect, is at that point right there. All right, so again, just solve for x or y in one of your equations and substitute it into one of your other equations. All right, and then the last method that we're going to learn in this video is elimination. All right, so the first example we're going to look at for that is going to be 2x plus 3y equals 6 and 4x minus 3y equals 10. And what you're going to do for elimination is you're just going to add these equations together. All right, so combine your like terms in both of these equations. So 2x plus 4x is going to be 6x. And as you can see here, 3y minus 3y, that's going to go away. So you're just going to be left with a plus 0 right there, and you've completely eliminated your y. All right? And then that equals 16. So you can get 6x equals 16. You can solve for x, which is going to be equal to 16 over 6, which divide top and bottom by 2, you're going to get 8 over 3. And then you can just, again, take this and substitute it back into one of your equations and solve for y. All right? Just like we did above. Now, looking at another example, if we've got x plus 2y equals 9 and 5x minus 4y equals 20. Now, if we look at this, if we were to just add these straight across, we're going to get 6x minus 2y equals 29, but we still have two variables in here. Unlike over here where one of them went away and we were just left with one variable in our final equation, we've got two. So we want to eliminate an equation. So in order to do that, we've got to either match up our x's, match up our x's or match up our y's so one of them gets eliminated. So in this case, I can see that if I were to times this value right here by a -5, it would eliminate our x variables. So I'm going to go ahead and just multiply this whole top equation by a -5. And we're going to be left with, if we bring that down here, we'll get -5x minus 10y equals -45. All right, and then we're going to add it to our second equation, which is 5x minus 4y equals 20. And again, add those together. This will get eliminated because we just multiplied it by that -5, right? So we're going to be left with -14y equals -25. All right, solve for y. It's going to be 25 over 14. You can take this, plug it back into either one of your equations, and solve for x. And it's really as simple as that. All you have to do is get one of these equations, you're going to multiply it by something so that one of your variables gets eliminated, and then you can solve for your variables just as we did in the substitution method. Now, all these methods are going to get you the correct answer, so it's kind of up to you whichever method makes most sense to you and whichever one you're most comfortable with. Go ahead and just use that one.